All right, welcome to the real part of this lecture. Let's talk about OOP, which is short for Object-Oriented Programming. So there's a lot of things that I got to get out of my brain and into yours right now. Don't worry too much about it because you can always come back and rewatch this lecture, right? I think a great way to make sure that you've understood things is to like blindfold yourself, cover up my code, and try this out yourself. I think that would be a great way to practice, and then you can yell at me if you're confused about anything on Discord or come to office hours. There's always a way, all right? So yeah, let's get right on into it. I want to explain something that I do with this class. I like to give a lot of in-class exercises, and if this were an in-person lecture, I would be splitting people into groups and doing what's called peer instruction, which is really cool. And if you're one of my online students and this is the first time you're watching this lecture, I think it would be a good idea for you guys to feel free to respond on the Discord if you want to some of these first questions where we're just trying to figure out the makeup of the class, because they don't tell me your majors and stuff like that. That's some of the questions that I'm asking right now. So, but usually I'll ask content-based questions, of course, from now on, after these first few ones to just introduce ourselves. But in-class exercises are abbreviated as ICES, and our mascot here at Clovis Community College is called the Crush. It's a bowl and it's like a weird color and it confuses me. But obviously that means that our in-class exercises will be called crushed ices, of course. So yeah, if you'd like to respond on the Discord, if you're an online student, let's figure out our majors together. Like, what's your major? I assume a lot of us are going to be computer science or like engineering. So I've also got like a data science class going at Clovis right now. So respond with your answer, at least in your brain, to that first question. Another question that I ask my in-person students is just like, how familiar are you with the Unix/Linux terminal? Have you seen it before? It is something we teach in CSCI 40 here at Clovis. It's something we require of our students. So if you've never seen it before, then it is going to be a little bit difficult for you to get the ball rolling here. But I'll be here for you. Your peers will be here for you as much as possible. You can go to the tutorial center. So I assume, I'm hoping that you're going to answer at least B, but if you're answering A, don't worry, we're here to help, all right? But we got to get you up to speed quickly. And then the last question is, have you ever made your own data structures before? Because this is a class about data structures. Have you ever tried this yourself? And so maybe one of these answers is you. If you pick D, maybe you can take over for me if I'm ever sick one day. So there's that. So yeah, those questions at least ponder in your head. If you're an online student, feel free to respond on Discord if you'd like. You guys can form a little community there. And yeah, I'm here to help, especially with the terminal stuff. We'll get up to speed together. All right. So now let's talk about C++. All right, let's talk about some things that kind of get us ready for where we're going, because we're trying to go to OOP, right? Object-Oriented Programming. So let's talk about some of these ideas that maybe you haven't fully seen before. Namespaces is something that's kind of a little weird, but it gets us where we need to go. You've at least said the word before for sure in C++. So let's talk about a namespace, because we've used this, right? We've said, for sure, we've said using namespace standard, haven't we? So we've said using, this is my first time writing words all summer break. So I'm going to be writing a little bit slower than usual for this first lecture. Namespace standard. Boop. So we've said that, but what does that mean? So all it is it's a space for names, right? So it keeps separate things with the same name separate. You can kind of section off your code, because normally we're talking about namespaces. Here's how you can actually make it your own namespace if you want to. You give it a name, and then between the curly braces, you say what lives in the foo namespace. You can do the same thing with a bar namespace. And then you can put two f functions if you want, because you know that if you did this outside of everything, you had two f functions, the compiler would complain about the second one, right? It would be like I is a redefinition of function f, right? But if you do it here like this, then it can differentiate, right? You're able to say, oh, I want foo's f, and there's no clash. I want bar's f, yeah. So the way that you call them is you have to use the double colon. So you say, I want foo's f. Foo's f, call it with 5. Bar's f, call it with 5. And that keeps the compiler happy, right? That's what a namespace is. It's just a place where names can live. So, and actually that's why we say using namespace standard. All the things in the standard library live in this standard namespace. So it's like somebody said namespace standard and define like cout. and cin and all those things. That's where they live. And so that means then that if you want to write your own cout, and maybe you do one day, you can always get back to the standard libraries version because they're using the standard namespace. That's the whole point of it, okay? And so yeah, you know how to import every piece of a namespace into the top level so that you don't have to qualify it using the using keyword. This means that I don't have to say standard : cout, I just say cout now. And but it's useful to know where it comes from. All right, so that's the secret sauce if you've never been taught that before. I want you to think of that : because it's going to pop up a lot, right? Especially in class definitions. Think of it like apostrophe s. It's like, I want this thing out of this guy. I want foo's f. I want bar's f. All right. Let me check my notes and see if I want to actually program any of this. I think it's kind of self-explanatory. So let's keep this on the screen, and you can try this out yourself if you'd like. So there's that. Yeah, let's next talk about implementation files and header files. It's possible that in your CSCI 40 class, you were taught just to write programs all in one file. That gets really unwieldy real quick. So I want to teach you, if you haven't seen this before, how to separate your programs. This is something that we teach in our CSCI 40 classes. So at Clovis. So usually you're going to want to separate things logically across file names. And so the idea is you write a bunch of code in a bunch of different C++ files. So .cpp is what I'll use for this class, but there's other extensions for C++ files. There's .cc, there's .cxx, and maybe that's one of those is one that you used in a previous class. But I like to use .cpp and .h because that's what my CSCI 40 textbook used. And so you put code in implementation files. That's like bodies of functions and methods and things. And then in header files, which end with .h or .hpp or .hh or .hxx. The x's, by the way, are because you can't in several operating systems have a plus sign in your file extension. And so the x is meant to be like a sideways plus, which is a little bit of history for you. So yeah, the header file is a file that contains just declarations of things so that you can eventually like implement them in the corresponding implementation file with the same name, okay? So you put declarations of functions and classes in header files, and that's what people include. They include your header file, and then they can use your library. It's essentially you're making a library when you split things up in this way. And as long as you compile with all the implementation files, it all works out. So that's a lot of words. Let's talk about that. So a header file is a file that just contains declarations of things. An implementation file is a file that just contains, it contains implementations of all the things that you promised to and declared in your header file. So yeah, I'll talk about some of these things, like that's an important thing. We'll get to that. So we'll talk about header file guards, but let's make a library. All right, a library with one function in it called add1, a function that adds one to another number. All right, so I want to make a bunch of programs right now, or a bunch of files right now that can like combine together to create one program. So I would like to make an add1 library in this way. This is my add1 library. I'm going to make these two files that correspond to it, my add1 library. And they're going to wrap around the idea of an add1 function. So just a function that adds one to whatever it's given. So in my header file, I'm going to declare an add1 function. And in my CPP file, I'm going to implement the add1 function. And then in main, and some other CPP file, which maybe I'll call main, is where I will import my library. I'll include my library so that I can use it, but all the real code lives there, right? I'm bringing it in. That's what it means to include something. So let me show you that all of that, show you how to compile it. It's really, really cool and really, really useful. I'll put all my library stuff for this first example in a folder for this lecture. I'll call it add1 library. So I'll put everything in there and I'll cd into that. So that's where I'm going to work. Nice blank folder. I'll get over here, down here as well. Boop. All right, so I'm in my add1 library folder inside of my lecture 1 folder. So when you look at this code from class, you'll go there. And so I want to make those files. So let's make an add1.h file first. And that's a header file. So it has just declarations of the things I'd like to put here. So declarations go in header files. And so what I want to declare that there's an add1 function. Let's just do it on ints. So here's my add1 function. Okay. That's what you put there. All right, and then in a corresponding add1.cpp file, let me see if I can split screen it. If I do an add1.cpp file, what you do, this is my implementation file with the same name. All right, and this is where you put the implementations of your code that you promised to create from your header file. So implementations, go in the implementation file. It's a long word, you can't see it all. Cool. And so I need to implement add one over here. That's the setup. And so how do I implement an add one function? I will return x plus 1. Yeah. So that's my library. And customarily, what you do is you, even though this is not necessary, you include your header file from that library in the implementation file. This will become very, very necessary when we start doing class-based stuff, because we need the declaration in this file, but is not necessary for this particular example. All right, so that's the file structure. That's the file structure, just like that. And if no one has told this to you before, what happens when you say include is it just copies and pastes the file. So this code is getting copied and pasted when I say include right to here. And so some wonky stuff can happen if you like accidentally include yourself, and I promise this is actually possible, just in a weird way. What if I did this? I include myself in myself, which is going to copy and paste this entire file when it's compiling right to here. And it's just going to like continuously add another copy of this. It's going to keep doing that. Does that kind of make sense? Because if it copies and pastes the contents of this file, it's going to like, all right, this entire thing goes where the include went. And so can I copy and paste this easily? It's like it turns it into that once it includes it once, but then it's like, oh, I see another include. So it keeps going forever and ever, and that's not good. So what we like to do is we include what's called a header file guard to cut that off. All right, and it looks like this. It looks a little weird, and they keep infinite inclusion from happening. Let me spell it out just once. But what you say in your header file is you say if these are number sign things. Oops. And this is just like include. It happens before C++ the compiler takes over. This is called preprocessor stuff, preprocessor directives. So what we do is we make a little before the compiler level variable. We say if something is not defined, and I'll call it add1 underscore h, because you can't have a dot. It's like a constant. So if you've never seen add1 h before, this label, then let's define it to exist. And you can say define it to 42. You put a space and you say what it is, or you can just say it exists. And then kind of like the curly braces of this if statement that's at the compiler level, you end it with an end if with a number sign. So that's called a header file guard. All right, an include guard. So it looks a little weird, but this keeps infinite inclusion from happening, because if it's seen this add1 h thing before, then it doesn't re-add everything, if that makes sense. All right, it's a little weird. I'd be happy to explain that more, but this is all we need right now. All right, it's called a header file guard. It keeps infinite inclusion from happening, and now you can actually do this. You can actually say include yourself in yourself. Oops, why is that not working? Oh no, it got unhappy. You can actually do this now, and it will be happy, and it will compile, which is crazy. All right, but okay, now I've got these files. I've got this add1.h, add1.cpp. Let's split screen in this way. So there's let's put the h file up here. Let's put the cpp file here. And then let's make one more file that uses all this. All right, my main file, main.cpp. So what I'll put in there is just a program with a main function. And it will include my library, include add1.h. And it's happy. And now it knows that there's an add1 that exists because it's getting this file. It's getting the contents of this file. So it knows that there's an add1 that's I've promised to make somewhere. We're not giving it this file. We're going to compile against that, though. We're going to link it. So once I say this, now I can use the add1 function. Awesome. And let's ask the user, hey, enter a number. And we'll add 1 to it, yeah? And then we'll output the result of calling add1 on that number. Awesome. And so these are all working together now. So like we've declared our library here in this add1.h file. We've implemented it here in the add1.cpp file. And we've used it in a separate program that's included our library, just the header file. That's all you need to know how to call it, right? We don't need the body there. But we're calling it, and then the last piece of the puzzle is to bring all these guys together, all these 3 files together in some way to have a runnable program, okay? So that's the goal. we did it. All right, so now we want to compile. All right, if you've never compiled a program on the terminal, we use the G++ compiler in this class. It's short for the GNU C++ compiler. It's made by a fun group of people called the GNU group, and GNU. I encourage you to look into what it stands for because it's a recursive definition. It's fun. So I've got these three files. All right, I've got add1.cpp. I've got, bear with me as I learn how to write again. It's been a summer. Add1.cpp. We've got add1.h, and then we've got main.cpp. And the goal is when I included, right? When you say include add1.h, it copied and pasted the add1.h file like into this main file. So I don't actually need to give this to G++. It's in there. It's been copied and pasted everywhere it needs to be. So I don't have to worry about this anymore. It's been included already. I just need to kind of show main.cpp, who is using this add1 function, like where the actual body is, because it needs to know how to actually run the code. So I need to somehow bring this guy into this guy, or bring them together, like show them they both exist, kind of. All right, but I want something from add1.cpp to be used in main.cpp, the actual body of the code. Okay, so what you do is you say G++, and you give all the implementation files that need each other. All right, so I'll give add1.cpp and main.cpp. I don't need to give add1.h, all right, because they're already copied and pasted with the include. And then I say -o. If I just say this, it makes a file called a.out in my current directory, which is just a weird default name. If you want it to be called something normal, you say -o and then what you want it to be called. And so it will make this file called whatever you give here. Okay, so we can now compile it and run it and link it, right? This is called, we're linking these two pieces of code together. This add1 main.cpp and add1.cpp. So G++, I want to give to it, I want to give add1.cpp, and I want to give main.cpp, and I want the final thing to be called, let's have the running program that I want to finally use, let's have that be called main. It's my main program. And so if I get no errors, it will make this new file called main, which I can run with a dot and a slash. The dot in the terminals just means current directory. So in my current directory, try to run this thing called main. And then here it goes. Enter number 42. Hey, we get 43. Awesome. You can rerun it. You can press the up arrow to get out your previous commands on the terminal. Enter number 55. 56. Yay. All right. So that's great, right? That, in a nutshell, is us making a library. I got a header file working together with an implementation file. That's my library, my add1 library. I can include it wherever I want, as long as when I compile, I give it in addition to the file it's using. All right, so you can do this. You can play this game all day long with a bunch of different libraries. You just bring them all together at the end here. Okay, so yeah, please yell at me if you have any questions about this stuff. But we got some knowledge now. Isn't that great? I'm excited for us. So yeah, let's keep on trucking. We're working our way towards object-oriented programming. So let's next talk about structs, which is a way to structure data. Short for structure, of course. So let's make a program that keeps track of a couple numbers. All right, let's get a couple numbers from the user a lot. Let's just get let's have the user keep giving us numbers forever, potentially. And I want to keep track of how many numbers we were given, and then what's the largest number we've ever seen. Okay, does that make sense? Like we're getting an infinite stream of data. Like we're getting 1, then 2, then 42, then -5. I don't know. We're getting an infinite stream of data until maybe like -1. Maybe -1 can stop us. We're getting a bunch of numbers, potentially forever if the user never gives us -1. And what I want to do is do some analysis on the numbers we're given. So maybe this is you can think of this as like part of a pacemaker that's inside of somebody's heart that's keeping track of the heart rates that they've seen so far, because if you see that it's going erratic, you need to give the heart a little shock, right? So maybe this is part of that. This could totally be thought of in that way. So that's useful, right? Bringing it back to useful things. And so yeah, let's make these numbers and they keep getting updated, right? And we're going to compile it. We're just going to make one file. We'll be lazy, all right? And we'll call it pacemaker.cpp, and I'll make that back at the original level of our program here. So I was in this add1 library folder. I'll just go back out to the lecture1 folder. So ... brings me out. So now I want to make a new file called pacemaker.cpp. And so what I want is I want these two variables, right? I want a count variable, and I want a current max variable, and I want to keep getting a bunch of numbers from the user forever until the end of time. And I want to keep track of how many there were, 0 at the start, right? And then current max is weird because like I got nothing so far, right? So I don't actually have a good number to put here, unless I want to put could put like negative infinity here. If I wanted to, but I'd rather teach this to you in a different way. So I'll just leave current max undefined. All right, so forever, let's say we're a pacemaker and we're getting data from somebody's heart and the way it's beating. All right, maybe like the strength of the heartbeat. I'm not really sure. I'm not a biologist, you see. So forever, let's ask the user, hey, enter the next number, the next reading, right? -1 to get out of this. -1 to quit if you're tired of this. But a pacemaker, right, is never going to turn off. They're never going to give you -1. So some programs run forever. So okay, let's just get a number from the user, and then we'll see if it was -1. Then we'll get out of this, right? It'll stop our infinite loop because it was while true. It was going to go forever, but we're gonna stop it early now. And then, all right, if it's not -1, we're still in this loop. So we've got a good number that we care about keeping track of. So like, what do we do with it? We got to update count and current max, right? So if we got a new number, the count's just increased, yeah? So for sure, count plus plus. I've got one more number now, n. I've called it n. And what I want to do to n is I also want to keep track of the current maximum I've seen so far. So current max is undefined. So if this is the first number, count would be 1 now. And the first number I've seen is also the biggest number I've ever seen, right? So if count is 1, then my current max is that number, right? Current max is n. That's the first number I've ever seen. That's great. Otherwise, I only want to update current max if it's something bigger than the one I've ever seen, right? So if n happens to be bigger than the number I've ever seen, than the biggest number I've ever seen, excuse me. So if n is bigger than my current max guess, the one I've seen so far, the biggest number I've seen so far, n is even bigger than that, then n is my current max. It's a new current max. All right, current max is n again, all right? So we just saw a bigger number. So technically you could have combined this into just one big if statement with this ORed with this, but it's more fun this way. All right, so I hope that makes sense. This is keeping track of current max and it's going to update it properly. And then let's say at the end of this loop, when we ever get -1, we've got all our numbers. Let's print out our count and our current max. Okay, so if we ever plop out of this loop, see out count, and we'll see out current max. Cool. And so the bulk of the code, the cool part of the code is kind of here. And so let's compile and run this in this way. So I'm going to give my one file, I've only used one file, to G++, and I'll call the final output file, I'll call it pacemaker. That's what I want to run it as. And so I've made this new program called pacemaker. I didn't get any errors, so I can run it now. And I can say, maybe I should make this a little bit larger, dot slash, and it's a forward slash, it's leaning forward, pacemaker. And I hit, and I enter, and I go, and I say, I don't know, 1, 2, 42, -7, 5. And I'll type -1. And it's showed me that I've given it 5 real numbers, and the biggest one over all of them is 42. And it's always going to keep track of that properly, even if it happened to have been the first one, right? We'll just keep track of it there. So like if I gave 42 here, -1. Oh, sorry. 42, -5, 3, 7, -1. There. So I gave 4 numbers this time, and it still kept track that 42 was the biggest. So it's always going to find it right. And so that's a useful program, right? It's going to keep somebody alive, maybe. And that's great. So, let's spice it up. All right, so that's a nice program. Let's realize something, right? So these numbers, like this stuff that we care about from this pacemaker, these readings, these numbers that we're keeping track of, they're kind of linked, right? It's not just count and current max, they're separate. They're coming from the same source, right? They're influenced in the same way. They should maybe be not so separate. So let's group it together with a struct. We'll put it together, we'll structure it together, all right? So we're gonna make something called a struct in C++, and sometimes this is called a plain old data structure. It's something that just holds values, doesn't have like any attached methods or member functions, if you remember those words. So a struct is something that just holds a bunch of different values of different types at the same time. They all come together. So I want to make an object that holds all my statistics that I'm keeping track of, and I'll make a type called stats using a struct. So I want to be able to do this. I want to say stats. I want to make a new type called stats. That's not just like an int anymore. It's got a couple ints inside, right? I want to say stats s, and this s variable is where I put all the things I care about. It's going to hold inside of it. It's a box with boxes inside, right? So s will hold the count of all the values I've ever seen. It will hold my current max that we're keeping track of. And so now they're all linked together, and just for fun, let's also have it hold a vector of all the numbers we've ever seen. We'll call them nums. Yeah. And so every time I make something of type stats, which is a new type that I'll make, it packages together in whatever name we give it, all these different things. It's variables within variables. That's what a struct is, okay? So let's make that happen. So I want to make, and do pacemaker stuff with structs now. So I'll make a new file called pacemaker structs.cpp. I'll paste in my old stuff, but we got some other things to do now. So I want to use vectors. So instead of count and current max being separate, what I'd like to do is make a new type called stats. So I can just say, instead of all this, I'll say stats s. All right. And so these ideas, I want to make that part of anything of type stats. All right. So I want to make a new type called stats, and this is part of what's in it. All right. So I'll say struct stats, that's the name of it. And then inside I put what lives there, all the variables that live there. And I also want a vector of all the numbers we've seen. So let's put that there too. So this is what it means. And you also have to put, for weird historical reasons that I can tell you in office hours if you'd like to know, you got to put a semicolon right there. All right, so struct stats, and then this is what a stats is. Every time I make something of type stats, this makes a brand new type, like an s. This is what s has inside of it. It has all these things, all right? And I can keep that equals 0, but let's just for fun, let's just keep it as something that I can define a bunch of values in that are all just garbage right now, okay? So count is, it has no real value, but every time I make a stats, it's called an object. Every time I make a stats object, a variable of type stats, I get inside of it a count, a current max, and a nums, okay? So, this might be review for some of us, that's okay. So what I want to do, what did I do before, right? I set count to 0. I needed to start that out properly so that I could increment it properly. So I'll say s.count equals 0. It lives within it, it's a dot, right? So s is count, inside of there, it holds 0, and that's quite nice. So you go inside with the dot, right? So s is count, set it to 0, and let's do all the same stuff. So all right, this all lives within s now, right? That's keeping track of all the stuff together. So s is count plus plus. If s is count is 1, s is current max equals that number. Otherwise, s is current max is, if I see something bigger, then I need to reset current max for that reason now. And then the other thing I'm keeping track of is nums. And by default, that will start out correctly empty, which is nice. And so the only other thing I need to do, in addition to all these things, is I just need to add that number that I've seen to the nums that lives inside of s. So s.nums is a vector. And I've just seen one more valid number. I've gotten past the -1. It's not the -1, right? So s is nums. I want to push back to it that number n that I just saw. All right. So yeah, that's us packaging together all the values that we've seen in one data structure. All right. So we just technically made our first data structure in this class. That's pretty cool. So yeah, that's how that works. And everything else should be the same as s.count, right? Spoke too soon. S is current max. And then let's also print out all the nums. So sorry you can't see all this, by the way. Let's see if I can like give you the first half of the file and the second half of the file. And then let me like, there we go, something like that. And then let's do, yeah, that's kind of the file. And let's iterate through the nums and just like print them all out on the same line. So I'll say for int num in my nums vector, but the nums comes from S. S is nums vector. It's the nums inside of S. Let's print out that num and some spaces in between. This is called a range-based for loop. And yeah, then break that line so the terminal's happy. And so there is my program. And let's compile and run it. So this is called pacemaker structs.c++. Pacemaker structs. I'll call it exactly that with no extension as my final output. If I run it, let's watch it work. So like, all right, I don't know, 1, 2, 42, -5, 7, 3, -1. So here are all the numbers I got. There were 6 of them, right? And the largest value I ever saw was 42. That's kind of neat, right? There's other ways to program this, of course. You know that the count is kind of unnecessary if you're keeping track of nums. You can just do s.nums.size. That would totally work. But this is fine. We can change that later. All right. So we're packaging a bunch of stuff in one place that is a struct. All right. It's got a bunch of things inside of it that you can get at with a dot, and it's happy. It's a bunch of variables within a variable. All right. So every time you make a stats, it works like this. You can make another stats object. We say it'd be like stats s2 semicolon. It's another box with new things. I hope that makes sense. All right, so please yell at me about any of this, but we're on our way, right? So that's a struct. And now let's, just to make sure we're all on the same page, we've all seen classes at least once in this lecture, let's talk about how to turn this into a class, like a stats class, all right? So I want to talk about these things, and kind of the overarching idea is like, it'd be nice to have some operations associated with our struct rather than just kind of doing it all outside. Like all these things, these operations, they were part of the loop. And it's kind of us affecting S, but it would be kind of nice if we could like think of this in a different way. Like the metaphor could be like S is a person, we're talking to that person, the person like can respond. So we can just say like, hey, S, I have a new number, do what you need to do with it. Something like that. Okay, so let me show that to you. Let's talk about it. So we would like a class now. A class is it's essentially a struct with some functions baked onto it, so attached to it. Let's make a class that keeps track of all these statistics. And because we can talk to this class, right, we're able to send it little messages and receive answers. We're going to call it the statistician. All right, this is just like a popular example from an old C++ textbook that is still very useful. So yeah, here are the operations. This is how I want to interact with a statistician. All right. So every time I make a statistician, am I spelling it right? I hope so. I would like the following. Every statistician, we call the values of this type that we're making, we call them objects, by the way, because it's something we can like metaphorically understand as like something concrete that we can touch and like talk to, stuff like that. All right, so that's why we call them objects. So every statistician object has some data, just like we did before. It has some data that it's keeping track of. It's got like, here, give me all the nums we've ever seen, store all those, store the count, store the current max. So it's got some data, some ints, some vectors. But in addition, what classes let you do is it lets you talk to those objects too. So you give it some operations, all right? So we can say, hey, statistician, I got a new number, add it. I'll add a new number to you. All right, and like you can get past the new number there. Hey, statistician, give me the average of all the values you've ever seen so far. So like it's you talking to it. That's the metaphor, and that makes it easy to understand in that way. Okay, so let's do these operations. So I want to do an add number operation to like keep track of values, a get max operation, and an average operation. All right, so I want those things. And just for fun, I want to also have an init operation that initializes our statistician variables. We call them objects really when they're of a class or even a struct, to give them initial values just to make sure they're holding on to the right things at the start. All right, and if you've seen classes before, I'm going to just be a little lazy. I'm going to make everything public right now. We're going to learn it all together just to make sure we're all on the same page. All right, so I would like to do pacemaker classes now, of course. Maybe I should steal all this stuff. Pacemaker classes.cpp. And so what do I want? I want to turn this stats struct into a statistician class. So instead of struct stats, I say class statistician. And I hope I'm spelling that right. All right. And then I'm going to put, and you have to say public for a weird reason that I don't want to get into just yet. I'm going to keep all the things I had, right? This is the data. So every class consists of both data and operations. So the data is still there from the struct land. So it's just like we're adding new stuff. So there's also operations as well as data in a class. Okay. And so what I'll do is, let's see, how do I want to implement this? Yeah, let's do it outside the class. Let's be not entirely lazy. All right. So I want the following operations. I want to be able to say init. I want to be able to say add number, like these guys. I can, in theory, I can operate. I can just like copy and paste. So I want to say add number, and somebody gives me like a number n. I want to be able to say get max. Give me back the max, please. And then I want to say, give me the average of everything you've seen so far, statistician. All right, and these you just declare, understanding that you can access all these things. You just declare kind of like functions. So there's an init method, and every time an operation is part of a class, we call it a method or a member function. Okay, so then we do void add number. It's going to be, and it's going to take a number n, that's an int. Get max will give back an integer because the max of a bunch of ints is an int. And then average, you know that the average of some numbers like 1 and 2, that's 1.5. So the average of a bunch of ints can be and should be a double, right? Because sometimes it has some decimals, even if it's a bunch of ints. So those are the things I want to implement as part of my class. And then let's implement those things. So let's just pretend we have them. I haven't given these bodies yet, right? So let's do this and figure out how things need to change. So I want to say like statistician s this time. Yeah, I want to say statistician s, and I would like to say, hey s, instead of putting this here, I want to have s initialize itself. Just say, hey s, initialize yourself, please. Do whatever you need to do. That's quite nice. I don't have to worry about thinking too hard about each time I make a statistician object, like what do I need to do to it? Just have init take care of that. Do it once and for all. And then this is also nice, right? Instead of all these things, like messing with the s object, I'd like it to just like do it itself. I want to say, hey s. Again, let me split screen so you can see like these are the things I want to be able to do. Really, all that stuff that was there, it kind of corresponds to the idea of, hey, s, I just gave you another number. Keep track of all your statistics, please. Hey, statistician, do what you gotta do. And then all these things down here we'll have to deal with as well. It's s account, s current max. We're gonna get a function called get max instead of current max, but this works too. So like get max instead of that, hey, just give me back your max, please. And yeah, I think that will mostly do it. I should also call average, right? Cout s dot, hey, tell me your average. And I think that's me using everything. So we've called init, we've called add number every time we get a new one. We're gonna get the max back instead of just like printing the dot current max. Really, that's what it's gonna return. And then average, we're calling it. All right, so let's implement these things. Okay, so the way that you implement these classes, these methods of a class, you do it outside, that's the non-lazy way. And when you put bodies of methods outside, it kind of looks like they're functions, right? So it's like init, it's like a void function. Like you can call it just by itself, but no, it's meant to be part of a statistician. It's like s.init. So we need to tell C++ that no, this is not just a function that is outside of anything. It's part of statistician. Every time you make a class, it secretly makes a namespace. So I'm saying, hey, C++, this is init from the statistician class. It's really a method. It's really a member function. Here, now I know in the body I'm able to access any member variables that I own. Okay, that's quite nice. So yeah, hopefully these words are coming back to you. We teach classes in our CSCI 40 class. I think it's required everywhere. It should be at least. But don't worry if not, like we come to office hours, we can talk about it some more. All right, so what does init need to do? It just needs to like initialize everything I care about. So we said, and you can just talk about your member variables, like count is 0, my count is 0, whoever this init is being called on. Really, it's going to be, we call this thing S. So it's S is going to be is alive right now when we talk about init, but set the count of whatever thing we're calling init on to 0, please. But actually, just for fun, to spice things up, let's pretend that there's always one number initially in our statistician. It loves the number 42. So let's say that the number 42 is the one and only number in our statistician at the start of time. So the count's really going to be 1 then. All right. So let's say that the count is 1, and the nums is empty. So we'll say nums push back. It'll start out empty. So push back 42, so it's in there now, right? Or I can just say that nums equals 42, just to make it clear. Nums is 42, which implies that the count is 1. I don't know the order doesn't really matter. And then the current max is just the one thing there. It's the 42. All right, so like that. Let's say that that's what it means to initialize a statistician. My statistician always loves the number 42, so that's a number that's always in there. Okay, and then let's do the rest. So add number. It's statisticians add number. It's not a function, it's a method. Statisticians get max. Statisticians average. So this lets C++ know that we can access member variables, like it's part of us. Okay? And so what do I need to do? What do I need to do to add a number? It was all those things that I deleted. All right, so let's go back. Let's go back to the struct one. So what happens when I add a number? All these things need to happen, right? No, sorry, structs. So this is the structs version. All these things need to happen. Yeah? All those things. But we're going to need a different name, of course. So it's my numbers, right? My own numbers, push back in. My own count, increment. My own count, if it's 1, this matters. It's always going to be more than 1, actually, though. So we can technically get rid of this if statement, because we're already starting out the count at 1, always. But that's fine. It's our own current max. And I think that's everything. Okay, so that's us changing our implementation to work properly with all this. And then get max is easy, right? We already have a current max variable that keeps track of the maximum. So just like give that back. Return our current max of our object, and then average should go through all the nums and find the average. And it needs to be a double, right? So the value that I give back, let's start it at 0 so I can add everything in, do my work, and I'll return the average in that average variable there. Okay. So how do I calculate the average? For every number, call it n in my nums vector that's part of me, I want to add my n into this average variable, and then say average equals average divided by the count. I could also have said nums.size, but count keeps track of it too. So that should work because average is a double. As long as one of these sides of the slash is a double, it'll work out right. Okay. One thing that I don't do in my CSCI 40 class, and I'm going to start doing now in my CSCI 41 class because we're more advanced now, is I always made a point to always use curly braces for bodies of things, even if there's just one line. If there is a one-line body of any, like a loop or an if statement, then you don't have to have curly braces. The reason I teach this to CSCI 40 and always use curly braces because what if you wanted 2 lines? You might think that indentation is enough, but really this is not going to be part of the loop. Like n doesn't exist anymore, it's unhappy. So just be careful. Sometimes I just put them all in one line. This works like that, but this is the one line body of the for loop. Okay. So yeah, that's my average. I think that should be everything as far as I know. So here are my operations, and they're working on this data. So I've made this statistician object down here in main. I've initialized it, so it ran all this code, set it to 42, and then I keep on adding numbers, and look how clean this while loop looks now. It's like, all right, just do what you got to do, statistician. I trust you. And then we'll give back all the things, and it's happy. All right, so all these implementations, I hope that they're making a little bit of sense. Hope that they're mostly a review. And let's compile and run. Classes, pacemaker classes. And so let's give it a bunch of numbers. So it's already got 42 inside of it. So I need to go bigger if I need something bigger. So like 1, 2, let's do 55, 33, -1. So it's always got the 42 in it, right? So what is the count? The count is, yes, those 5 numbers, 42 counts. 55 is the biggest one, overshadowed the 42, and apparently the average is 26.6. So that was necessary that we had a double that we gave back. Great. Okay, so yeah, this is a good file to study, I think. We're gonna spice it up even some more, but this is what it means to be a class. You've got some data that you're keeping track of in every object, and every object also has some operations, and you think of it like you're talking to that object, like, hey, statistician S, go and initialize yourself, add a new number, do what you gotta do, mess with your own data. We trust you, all right, in theory. So yeah, with that in mind, let me give you all this code so you can look at it for a second, but I have a question for you now. Here's the first 2 methods. You got init, you got add number. Boop. What I want to do, I'll make these big in a second, but what I will do in my in-person class is split all my students up into groups, but you can work on this. Just pause the video and work on this by yourself. But let me give you this code. Let's get max and average in there. What I'd like you to do is order this code, because one of the pieces of CSCI 41 is learning about how to like analyze how fast code runs, right? So here, I can make this as big as I can. I'd like you to order these methods: init, add number, get max and average. Order them from fastest to slowest. Which of these options do you think is right? Please pause the video, look at this code, try to imagine. What do you think? So assuming you gave it a good try, and I really hope you did, because this is legitimately part of the class. We need to get good at this. Let's try to analyze it together with our current knowledge. We're going to get better at this, of course. But with our current knowledge, let's try to understand, all right? So like, okay, I think we can all probably agree that one line is very fast to run, right? So like get max better be the fastest. It's just going to return a value we've already got. So I'm pretty confident that A and B are not included here. So I think get max is probably the fastest. And then let's see. Then we got 3 lines for init. This is quite a few lines and if statements for add number. So it looks like add number is probably more complicated than init, I think I would say. It's init is faster to run. And then average, let's see. Average has a few lines, has 4 lines. So like, does that mean it's less than add number? I think init's probably next, right? So get max init is probably the right order. It's one of these guys. And then is it add number or average and add number? And my answer is, if you think about it, like maybe you have an idea in your mind, it's actually going to be E. All right, and let me try to prove that to you. Do you see how this for loop is key? If nums, what's the smallest nums could be, by the way? 1. If nums was size 1, it's only going to run this body once. So it's really, it is legitimately running 4 lines if nums has 1 thing in it. Does that make sense? So it's going to be faster than add number, who has like a few different lines to run, has some if statements potentially. It's going to be faster, or if not the same, right? Because it'll pick only one of these bodies. Just think of it that way. It's going to be faster, if not the same speed as add number, right? If the size of nums is 1. But let's say we've put a few nums in our nums vec. If our nums vector has like 100 things in it, then we're running this body 100 times, and it's way slower than add number. Do you see that? So it really does depend. And that's something I want you to get good at noticing. All right. So don't worry if you didn't notice it this first time. That's the whole point of you taking this class. But do you see that there is more to learn? All right. I hope you see that, and that's great. That's really good, and hopefully you want to learn more. So yeah, let's try to do that. Boop. Dun, dun, dun. So here's our stuff. Let's try to make these nice and small. You can always go back to the real code or the previous slide. So, oops, sorry, I'm punching my microphone. So init is like, okay, that's 3 lines. Not horrible. They're just like setting values, 3 lines, not too bad. We're gonna get much more, like, much better at this. We're gonna make this more precise later. Not too bad. Add number is for sure get max is definitely the fastest, right? Definitely the fastest. It only has 1 line. Just returning a value we've already got, does not need to calculate anything. And then add numbers, just like it's got a few lines, maybe an if statement, right? Conditional, goes down one of the bodies, maybe a few lines. Conditionals. It's going to test at least one of those conditionals, right? Potentially run a body if the first one hits. So you got to think about how it's going to run. And then average, that's the weird one. It depends, right? The speed of average, it depends how many times it's going to run the body of that for loop. And how many times it runs the body of that for loop depends on the size of that vector. Depends on the length of the vector. I hope you see that. All right. So that's crazy. That's good to be thinking about that. All right. So let's next talk about let's talk about public and private next. All right. So our current class doesn't necessarily have a problem if you've never heard of this problem before, but I think it has a problem. All right. There's an issue because we are allowing, like, I guess it has a problem if you really want to think about it that way. Because, like, inside of the statistician class, we've got a count, right? We've got this count. And, like, you're allowed to touch it, right? I can say s.count right here, but I can also say that. I can be like, s.count, you know what it is? It's -4. I can totally do that right now. And that is bad. Yes? That is horribly bad. So we would like to not let that ever happen, right? Because, like, it's add number that should mess with the count for us. Count should not be something the user can, like, set. Maybe we can look at it, but the user shouldn't be able to set it because, like, it depends on how many numbers we're given. It shouldn't just be allowed to be just some random int value. Does that make sense? We don't want the user to access count. For similar reasons, we don't want the user to access any of our data. Yes, we've marked it as public, and public means I can get at it. I can use the dot, I can get at it. All right. So we don't actually want to be able to modify any of our member variables outside of our member functions. So statistician, like, it knows what it's doing. We trust the implementation of this class, but we don't trust main who's using the class. All right. So let statistician mess with its member variables in its member functions, or its methods, another name for a member function. Let it do that, but don't let anybody else touch this stuff, all right? And the way we deal with that is we mark it, public implies the existence of private, right? So we make it private, all right? Because we know what's best for our class. Main has no clue what it's doing. We don't trust anybody who uses our class. We're the implementers. We should have the final say, all right? So let's make all this data private, okay? And what that does is it means we can't use the dot anymore, all right? What it means is we can't use the dot anymore outside of the class, all right? We can for sure still, this will all still compile. We can still touch our member variables inside of a method. It's part of the class, but down in main, we can't say dot anything and talk about any of this private stuff now. So we can't say dot count. That's what we wanted, right? Because being able to say dot count to get the value also lets us use it to set the value. So what we want instead, the way that we let the user look at the count is we got to give them something public that won't mess with anything. So we give them a method, all right? So we say, we're going to make a method called, let's say, get count. And then the user can say, hey, just give me that count, please. And then they can't mess it up. Yeah, then that's fine. So for similar reasons, we made get max just to try to show you that, like, there's a way forward. It's a very quick answer, okay? And then same for nums. Like, you want nums, we got to give that back to the user, right? We got to say vector int get nums. Give that back to them in that way. Have it be returned to them so that we can say get nums. Now the user can't mess with the nums vector, yeah? We're just giving it back to them. Isn't that nice? So if we wanted to be fancy, I could return this as like a constant reference. I could have said this, but just for fun, let's just give them a copy. We'll deal with that later. All right. And I think that should do it. We still need a body for these things, of course. But yeah, there's no underlines in my editor anymore. So we need to give the user these, they're called getters, right? Because they're giving back a value. They're getting a value for the user to use. And do I just want to put these in order? Yeah, let's put them under average. And so that's great. This is my new operations, right? Get count and get nums. We need those. That keeps us safe. All right, this is the statistician classes get count method. This is the statistician classes get nums method. And these just return our member variables. Return the count member variable. This returns the nums member variable. Yeah, and so it's going to work and it's happy. And now I can't mess with any of this stuff. I can't reset it in main. The user can't do anything weird. All right, which is great. That's what we like to see. Okay, so with that, I think we should be good. Like all this stuff is still the same. We're just using it a little bit differently, but we've made it work one more time. All right, we've made it cleaner. We now don't have to trust the user at all. 3, 4, 5, -1. So 42 is still the biggest. There's 4 numbers, including the 42, that is the default, and the average is that. Everything still works, but do you see what we needed to change? Get count, get nums. We're just asking the statistician object, do what you got to do, give me the stuff back, please. We're interacting with it in the way that it is defined as, and saying what it allows. So the stuff that's public is the stuff you, the user of this class, can do. The private stuff is for the class itself to deal with. You are not allowed to touch it. And that's really, really powerful. It's called access control, right? It's giving you a lot of power to make sure that the user is not going to mess up things. As long as you give them as few public things as possible that don't mess with too much, then you can have some very good guarantees about what's going to happen when somebody uses your class. Okay? That's pretty nice. Sometimes you do want to give somebody access to a private member variable. You're like, you come along and like, okay, there's this one function that I guess I trust. Let's give them access to my private pieces of me, which is usually just going to be your member variables. It is possible to make private methods, but I won't show you that here. All right, not right now. So let's make a add one to every number function outside of the class. All right, and here's its goal. I'd like to make a function. This is silly, it's very contrived, I know, but this is just a good example. I just want to add to this example and show you all the things I want to show you. All right, so I want to say add one to every number, and we're going to pass, it's going to take a statistician object by reference so that it can mess with it. And what I want to do is I want to go through in this statistician object. I want to be able to do this. I want to be able to go through every piece. I'll use a normal for loop this time. Go through s.nums. And I want to mess with s.nums at I. I want to go to every index of s.nums and increment it. Add one to everything. All right. And also that's going to increment the current max. Whatever s's current max was, because I'm adding one to every number. If it was 42, now it's 43, right? Because I'm adding one and I'm making that 42, 43. So every maximum increases as well, but the count stays the same. I want to do this. This won't work, right? This won't compile. Here, let's watch the compiler complain. Oops. Recompile. It's going to give me a few errors. Be like, declared nums is declared private, .nums is declared private, .current max is declared private. So it's going to say that a bunch of times, okay? Because these are all private things I'm trying to access, and this is just a normal function. It's not part of the statistician class, yes? So if I want to give, I trust this function, and I want to give it and it alone access to my private member variables so it can actually mess with pieces of a statistician object, private pieces, then, because none of these public methods let you do this, right? You need access to the private things, or you give it a public method that does this. You can mark, it's really a cute metaphor. You can mark this function as a friend of the class. Isn't that the cutest thing? Because it's your friend, you trust it, and you're able to give it access to your private things. So for us in this example, it's member variables. You could also have private methods though, okay? So this class, it's statistician. It's the class itself who decides who its friends are. So it's kind of like a one-way friendship, but this is what it lets you do. Okay, so let me move this out of the way for a second and go back up here. What you do is you mark this function as your friend. So let me get the name of it and the first line of it. So this is what you do. And it's going to look like a method declaration, but it's not. It's a friend declaration. It's a friend function declaration. So I say that this is the declaration of the function I care about giving access to, and I say it's a friend. So this does not make a method, does not declare a method. It says that this function, this is another function you'll see, C++, it's a friend of mine. It's able to access my member variables. Anything private, let it have it. All right, so we're just saying it's okay for this function. And it's a function, by the way. I'm not making a method to access my private member variables. Isn't that fun? That's such a cute metaphor. So by marking it there, in that way, and now I can bring this back in. So we just declared its the fact that it exists. We marked it as a friend. Now it's happy and it works. Isn't that fun? That's so cute. So let's call it before we print out anything. So let's say add 1 to every number, and I got to give it a statistician object. I'll give it rs. Okay. And so let's watch it work. Recompile. It's happy now. Rerun. So like 2, 3, 4, -1. Dun, dun, dun. Oh no, I've done something wrong. So we'll go back and we'll fix it in a second. But it looks like, yeah, it kept the 42, it kept the 2, 3, 4. So it didn't correctly add 1. And so maybe through the screen you're screaming at me like, what? Yeah, I know exactly what's wrong. How dare you? It looks like I'm not hitting anything. Did I just not call it? Oh, I didn't save the file. That'll do it. Sorry. 2, 3, 4, -1 now. There we go. We got 43, 3, 4, 5. Much better. So I just forgot to save the file. And now it's going to this code. It's running. It's messing with this S object that's passed by reference. So it's actually changing things of it. And it's messing with member variables. And that's okay, because we marked that as a friend of the class. That's so cute. I love that metaphor so much. All right, so that's what friends are for, guys, in C++. And I think that is mostly the end of this long example. So pat yourself on the back if you got through that. You're going to have all this code. I just want to add a little bit more on top just to get us all on the same page about testing. I want to be able to test this class. All right, so to get there, I just want to do a couple more slides, and then it's time for the lab. This is like a longer lecture just to make sure we're all happy, but you could watch it at 2 times the speed if you want. So, question of the decade. How in the world do we know that this statistician implementation is correct? We tried it on a bunch of inputs. Seems to print out the right stuff. How do you know? How do you know it's right? So, one of the answers is to run it a lot. But we'd like to automate that process. So we'll make a bunch of tests, and tests are just code that run some predetermined ideas. They like mess with the stats object that it makes in a certain way. And then you kind of run the code in your mind, you know what should happen, and then you like use an if statement to make sure that what should have happened. So that's all a test is. It helps you convince that your program's correct. So you write a bunch of tests. The more that pass, right? You want passing tests, not failing tests. And all a test is just some code that runs. It messes with something. It has predefined input, so you know what's supposed to happen, right? And then you compare what you see to what you get, right? So for example, I know that if I did it right, this code, make a statistician object, call it S, and say s.init, it should have set up the count, right? Count to 1, because you got that 42 in there, right? It should have nums holding just 42, and the current max should also be 42, but just I'll put ... Like this should be true, right? This is a condition that should be true. I can go and check that, can't I? And the count should equals 1. I can go and check that, can't I? And so if all of those conditions evaluate to true, then you're confident that the thing worked. So let me show you how to test stuff, right? So let's test our get max method, all right? In the following way. I'll show you a function called assert true that's going to do the heavy lifting of testing for us, but let's make this test case, all right? So I want to make a new statistician s, call init, and then get max should return 42 after I do that, right? That should be true, just like I drew. Then if I add 43 to s, like say, give it a new number, give it 43, then get max should have changed to 43. If I say s, hey, you got a new number and it's 44, then get max should change to 44. And then if I add a number and I say s, add a number 0 to yourself, then get max should have stayed 44, yes? So there's an order involved. So let's make that test. Does that make sense? So a test is kind of just like a function that you run, and it does stuff. Make sure something worked. So, yeah, let's make a test up here. I'll make a function called test max. It's just a function that runs a bunch of tests. And so let's do this. So these are the things, this is the pieces of the test. So I want to say, make a new statistician s. So you just like run it, right? Statistician s, call init, s.init, can't forget that. And then get max better return 42 right now. So what I want to do is just say like, hey, s get max. I can't say s dot current max, by the way, because that's a member variable. This is just a function, and current max is private. But I can say get max, unless I make it a friend. I can say get max better be 42 right now. Does that make sense? Like that's a condition I should be checking. And a standard way of checking whether something worked, you're kind of you're yelling to the world, hey, this better be true. Another way of saying that in like programmer lingo is called asserting. I want to assert that this condition is true. And so there's just a very common function in testing that's called assert true. And you just kind of give it what you want to be true in the description of the test and does the heavy lifting of like making sure it was true for you. So I want to make a function called assert true that takes a bool, right, the condition that I want to be true, and then like a description of that test. So like if it prints out that it failed, you know what failed. You also know it passed. And so I need the string library for that, for strings. And then kind of what assert true is like, hey, if B was true, another way of saying that, because if B is true, it will run its body. So if B evaluates to true, like if B gets replaced with true, you just say that. So this is equivalent to just saying if B. So if B is true, then passed. My test passed. And here was my description that I passed along of that test. Otherwise, it failed. Oops. And here's this description of the test. Does that make sense? Like you pass the Boolean that you want. So like here's me calling assert true, just like I say assert true, that this happens, that get max is 42, that's true. And then I can just like, here's my description of the test, like get max was 42, something like that. You can make just English, whatever you want to write there. So like that's part of my test. Does that make sense? And then assert true, just like making sure that whatever I pass here, that this is a Boolean, right? That it was true, and it prints out that it passed if it was. And so that's me writing a bunch of tests. So let's keep assert true at the top now. Oops, that's what assert true does. And then let's do the rest. So how do I add 43 to s? It's s.add number 43. Then get max better be 43 now. There's my next test. Make sure that get max equal 43 when you call it. Does that make sense while we're testing that? So this is just a bunch of conditions making sure that they did the right thing with assert true. And then if I add 0, get max better still be 44. All right. And so those are my tests. And I'm running this somewhere. I should run it somewhere, right? Let's run it down here at the bottom. It's just a function, test max. And that will run all this code, making sure that everybody's happy. Well, let me zoom out a bit so you can see it all. So there's test max. And then there's assert true. And I'll just type -1 because that's the other stuff. So here it is. All of my tests passed. So that means I can be more confident that everything is working out properly. Does that make sense? So that's pretty neat. That's what it means to be a test. It's called a unit test, by the way. You're testing a unit of your code. There are other kinds of testing, but this is the main kind of testing we're going to do in this class. And that's pretty much it. So that's the lecture that I want to give you. That's the main lecture. So it took about an hour. Good enough. And what I want to do next is teach you how to get on the class server, and this is kind of part of the lab time of this class. If this were an in-person class, I'd pause for a break right now because we have to have a break in between stuff, but you can just pause the video if you want. So come back when you're ready and we'll talk about how to get on the class server, and that will be all we do today, okay? So I want to show you how to get there. Just in case you're having any trouble. So here's how you do it. So if you are on Windows, you can use PuTTY. That's one way to do it. You can also use the Windows terminal. I'll show you how. But if you're on Windows, you can use PuTTY. If you're on a Mac OS, or if you know how to use like Windows terminal, like using PowerShell, or if you've already got your own version of Linux on your computer, then you can pull up that, and it's this command for you. But let me show you PuTTY. So PuTTY looks like this. Get that installed. The host name, sorry, I can't make this any bigger, but I can zoom in and I think you can see it. So this is gonna look a little weird. But the host name is server.lautensclass.com, server.lautensclass.com. That's the best I can do for you right now. And then port is 22, that's correct, and it's just SSH. All the defaults are right and correct. And then you hit open, and it might ask you, hey, do you trust this computer? If you've used the server in the past, like I changed it every semester, so it might be like potential security breach, like it is for me right now. It's asking you, do you trust the computer you're connected to? And I trust it. All right, so you say accept, and then here it says login as. All right, so your username and password, if you haven't done this yet, it's your last name underscore your student ID. Just like for the class website, same stuff, but same username, same default password, but the passwords aren't linked. So if you change your password on the class website, it's still the default here. And so I'll log in as my test student. I got a test student here, but it's your last name underscore student ID. All right. And I already typed it wrong, and so I'm gonna do it again, sorry. Let's close that. And I'll do it again, PuTTY. server.lautensclass.com. So log in as, now I know to type backspace rather than the arrow key. It's last name underscore student ID. Yes. And then you're going to type that all over again. Then you hit enter, right? You can hit enter, and then it's going to say, type your password, and you won't see any like stars or circles when you type the password. It's extra secure, but it's really getting your keyboard stuff. So you just type, and it'll go there. So I don't know if you can hear me typing right now, but I typed, and then you hit enter once you're done. And what will happen is it will ask you to change your password. So it'll ask you for your current password one more time, which is your username. It'll force you to change it, and then it will log you out. And then you just do the same thing again with the new password, and that should get you to the cow. Okay? That gets you to this. You're in your home folder. We'll talk about that in a second when I talk about how to connect for other people. To leave the server, you can say the following. You can say there's a command called, oh gosh, there's a command called exit. So to log out, here's how I want you to log out. Don't just hit the X. That kind of logs out in a way that's like, you know how you feel when like you take a nap and you're really tired and like you wake up and you're not sure what year it is anymore. That's what happens to the server when you click the X and you don't log out properly. So to log out properly, you say exit. All right, you say exit. That's a command called exit. You type that, you hit enter, or you can say control. Even on a Mac, it's control and D. All right, control, like D for I'm done, kind of. That's how you can think of it, maybe. And so if I want to log out, I can say exit and hit enter, and it will log me out properly. Close PuTTY. So if you're on a Mac, or if you want to use Windows Terminal through PowerShell or Windows Subsystem for Linux, then you're going to open up the correct program, and then you say there's a command called SSH. All right, you're going to say SSH, you're going to say your username, and it's kind of like an email. You say the @ sign and then the name of the server you want to connect to, and then you'll hit enter. Okay, so let me make a new window for myself. So if you're on a Mac, or if you're on Windows and you want to use Windows Terminal, or just like PowerShell or something, you say this. You say SSH space your username last name underscore student ID. And you say @ and server.lawtonsclass.com. By the way, there legitimately some student IDs start with a 0. So like if your ID starts with a 1, I think it's either a 0 or 1 for you. Like you just put a 1 there. You don't like prefix it with a 0 or anything. Some student IDs legitimately start with a 0. All right. And then you hit enter, and it will ask you, hey, do you trust the computer you're connecting to? You might have to type like yes and hit enter, but I've already done that. And so eventually you'll get to the password as well, and you'll type your password again. It won't give you any stars or circles when you type your password. But it's really good. Now you hit enter, and it will again, the first time you do it, it'll ask you to reset your password. So you type your current one again. That's just your username. Hit enter, type a new password twice, and then it'll log you off again. You'll do SSH all over again. You'll say all this all over again to get right back on. And once you get to the cow, you're in a good place. Okay. So, yeah, let me just make sure we can all get there. So please yell at me if you have any trouble as you're watching this. Come to office hours, talk to me on Discord, something like that. And do note that this server is not your own computer. You're connecting to a server that is far, far away, at least right now in the semester, or when I'm recording this. This server is in Germany. It can be anywhere, wherever I choose to put it, wherever was cheapest for me. All right. So every time you press a key, potentially your stuff is going across the Atlantic. And so I don't have control over power outages in whatever the data center they're using is. So just save your work as often as you can, and we should be in good shape. So you don't have to work on the server if you don't want to. You just got to turn the things in, like your labs in, on the class server. So if you want, like I can show you how to get Linux on your own computer. I can show you how to transfer files, to copy them. A cute program is called CyberDuck that you can download. There's other ones, there's WinSCP, there's other things, and I'd totally be happy to help you get like a C++ compiler installed on your own computer so you don't have to keep connecting to the server all the time. You just got to go and turn things in on the server, all right? So CyberDuck is an option. WinSCP is another option. Plenty of things you could do, all right? So that's one thing. And then, yeah, really the last thing I want to show you, last couple things I want to show you is just like how to move around on the terminal, how to use the terminal. Also called the shell. Do read. I gave you some optional reading on our Canvas about that, so feel free to read that. That'll definitely help you, especially if you've never seen this before. But let me just give you a quick overview of what to do. So when you log on to the class server, you're placed in a folder that's just for you. It's called your home folder. All right, it's shorthand is the tilde, but the name of your home folder is just like, it lives on the class server, and it's really a folder with your username in a folder called home. So it's like home/your username. That's where you are right now by default. So tilde is short for your folder. It's called your home folder. And yeah, by default, let's see, there's nothing here. So let me get rid of a bunch of stuff. Boop. By default, when you log in, at least, you type ls. ls shows the files that are in your current directory, and you're currently in your home folder. There's nothing there, and it'll just show you emptiness. All right. But if you want to put stuff places, you can maybe you want to make a folder for your lab. So you say mkdir, make directory. Directory is another name for folder. And then you say what kind of folder name you want. So make dir labs. That makes a folder called labs. If I say make dir temp, that makes a folder called temp. That's just for me. If you type ls now to list the files and folders in your directory, now you got some folders. Isn't that fun? And so yeah, you can go into a folder and start working inside of that. The terminal is always relative to where you are. So I can say cd for change directory into the temp folder. Now I'm working, and you can see that the terminal prompt changed as well. I get to see where I am and what's there. And now if I type ls now, well, pwd is print working directory, by the way. It shows you like the folder structure where you are. And so I'm within my home folder, which is a folder with my own name. And then I've gone inside of a folder called temp now, and there is absolutely nothing there, but we know that there is stuff in my home folder, right? So it's always relative to where you are, your commands. And so if you want to go back to your home folder, you can always just say cd tilde, no matter how deep you were, you can always get right back to your home folder, all right? And that gets you back to where you were. If you want to go back to the temp folder, if you want to go out like once, you know that temp was one out, was one inside of the home folder. So if you want to just like go back out to the previous folder, it's called your parent directory. There's a shorthand for that. It's called ... is always the name of your parent directory. It's shorthand for where you just came from, what folder you're inside of. Just go out one. So ... is just like go out one, and it brings me back to my home folder. See that? So that's nice. And so yeah, let me go back to temp one more time. And here is how, so yeah, tilde shorthand for your home folder. Let's make some file. Let's make a hello world program, all right? So I would eventually like you to use the program that I used in class today to write your code. It's called Vim. But if you've never used a terminal-based editor before, a terminal-based text editor, I want you to start with Nano and then quickly learn Vim, because Nano is horrible. We don't like it. It has some downsides, but it's good to get started with. So if you want to make let's say I want to make a file called hello.cpp. I want to use the Nano text editor, though we want to learn Vim as soon as we can. Here's how you do it. So I want to make a file called hello.cpp in my current directory. So I'll say Nano, it's just the name of the editor. It's called Nano. And then I say the name of the file I want to work on, nano hello.cpp. And once I hit enter, it brings me into this program where I can just start typing. It's like Microsoft Word, but text-based. And so I can write my code. Int main cout hello world and new line. Look how it doesn't by default keep the same level of indentation. Isn't that disgusting? Return 0. We hate Nano, but it's good to start with, all right? And so I've got my file how I want it. You can move around with the arrow keys. You've got to change something. That's fine. And then once I want to like save and quit, it's all together. It's called down here at the bottom. It's showing you like what you could do with Nano, and that's not much, to be honest. But this character means control. So if you type Control X, that means exit for Nano. And it's also it's promise it's control. It's not command on a Mac or anything. It's just control for everybody. So Control X will exit this Nano back to the terminal, and it will also ask if you want to save. So Control X is for saving and exiting. So I'm going to type Control X on my keyboard, and it says, do you want to save, Y or N, yes or no? And you could also type Control C to cancel. Like I didn't actually want to do that, but I'll say Y for yes. And it asks me what file do I want to call this? The same name as the one that I started with. So hello.cpp, it's already filled out. So I'll hit enter. And if I type ls, what do you know? I got that file. Isn't that great? And then I can compile and run it. G++, hello.cpp, -o. I'll call it hello. And then if there were no errors, it makes this executable file called hello that I can run with the /. Hit enter. Ta-da! Isn't that great? I love that. So that's all the things we did, and this is a good start. So please try all these things if you've never worked on the terminal before, and come yell at me at office hours if you need any help. You can also go to the tutorial center. It's a wonderful thing. And that's a good start. So get all that working. And then with whatever time you have left that you're willing to set aside, I would highly encourage you to learn Vim. Vim is the better text editor. It's much cooler. It's terminal-based still. And instead of nano hello.cpp, you would say, by the way, nano hello.cpp gets you right back to where you were. Gets you back to the same file. Instead of that, you could say Vim hello.cpp, but you can't use Vim yet because the meme is that nobody knows how to exit Vim. All right, so there's a tutorial for Vim called Vim Tutor, and I want you to do that. So just type Vim Tutor, it plops, and hit enter. It plops you into a tutorial for Vim. You can just start with the arrow keys to move around, and it will teach you how to use Vim and how to move around the Vim way as well with these keys. The very first thing it shows you is how to leave Vim as well. So moving the cursor, and then exiting Vim is the next thing. So if you want to leave, you say Control Q. If you don't want to save your changes, you do exclamation point. But I haven't made any changes, so I'll just say colon Q. But yeah, this will teach you how to use Vim, and it's much better and it's cooler. Look at Nano real quick. Remember this? Look at Vim real quick. We got line numbers. That's useful already. So do learn Vim, do the Vim tutor. You can save and come back. You can save your progress and come back. That's not a problem, but I highly encourage you to learn how to do Vim. All right, it's very useful. And that brings us to the end of the day. So we did our lab time as well as our lecture time. It's a lot, it's action-packed for the first day, I know, but we made it. So pat yourself on the back. Let me know if you have any questions, and I will see you in the next one.